Santiago, Nino, and Nicolas Polignan, and this is the automated bulk bag filler for Titan America. Titan America is sponsoring our project. So for those who don't know, Titan America is a materials company. They are the leading supplier of sand, concrete, block, and ready-mix concrete to all sectors of the construction industry. We are working specifically with the mine site here in Miami, Florida. So this project has the potential to have a large global impact to both society and construction industries. They can be, specifically for Titan America, exportation of aggregates using bulk bag fillers will allow them to be global distributors. Also, as you can see in the map, Titan America has multiple mine sites all along the East Coast, and these various locations could implement the automated bulk bag filler, and this would nationally increase profit. This is not only limited to Titan America, because other construction industries can implement this automated filler, and that would standardize the process for aggregate filling using bulk bags. So these are some of the standards that we've identified and implemented for our designs. Safety is one of the most important ones, being that this is an active mine site. But the purpose of these standards is to ensure the safe operation of the system and also of the workers, and to improve the quality of construction. This is also used for ensuring the compatibility between the various mine sites, and also to reduce costs. So why this project? Currently, there is no automated process for bulk bag filling. The process is done manually, and this suffers with loss in time, wasting material, and also a lot of manpower. So currently, the manual process takes 1 hour to fill 10 bulk bags. And there's also a lot of spillage and overfilling, and that is loss of material and therefore profit. So for Titan America, it's a very unprofitable product and process. So our objective for this project is to design, simulate, test, and prototype a filling structure capable of automizing this process.
So we have used at the moment the term aggregates, but what are aggregates? Aggregates is the number one mined component of the world, and we can see of every lifetime. For Titan America, aggregates is the final product, and it consists of sand, gravel, and crushed stone. Our project we build the structure for sand and gravel for a diameter of 1 inch of dimension or less. And now the flexible intermediate bulk container, most commonly known as a bulk bags, are bags made of waived polypropylene in order to have a rip resistance. The bags on itself has a weight between 5 to 7 pounds and have the different dimension and different load capacity between 1,000 and 4,000 depending on the necessity. At the moment, Titan America uses bags with 35 by 35 by 54 inches with about volume of 38 cubic feet. The safety workload is 3,000 pounds because this is the required, and with the safety factor 5 to 1, this is low, and for the manufacturing of the bags, it's not recommended to reuse because they are disposals. The bags have an open inlet filling and a disposal chute in order to have a faster disposal for the material. Now Nicolas talk about our design alternative.
Hello. As you can see from the picture, this is our first design alternative. We have one hopper, one chute, and a solid structure will be a concrete slab which will be placed at a specific location at the mine site. The flow rate will be controlled by the front end loader. The front end loader will feed the chute, and then by using the inclination of the front end loader, we control the flow into the bag. The bag we place down here with the scale down here, which we can control the accurate 3,000 pounds as Santiago mentioned, and they will be held up using clips to all four corners. Now, before this is our first alternative. Then we thought, how can we increase profit and reduce and increase safety? So thus, we came up with our second design. We still have one hopper, but instead of one chute, we have 4 chutes. Each chute will have a bag underneath and a scale underneath, so you can load 4 bags at the same time and control and load out faster. Also, another difference is instead of controlling the flow using the front end loader, we would have 4 guillotine gates, which we control using pneumatic. And that way, instead of using it, then you could free up the loader and control the specific weight using the guillotines. Another difference is, like I mentioned before, the first design, it was a solid structure attached to a specific location. This will be placed on a skid or a mobile structure. That way, we could transport the skid anywhere in the plant. The finished products in the plant aren't necessarily located all in one place. They could have, one could be 1 mile away, it could be 3 miles away, depending on it's a large mine site. That way, if we want to ship out different types of aggregates or screens or sands, we can move the skid around and have that opportunity. Also, the mine site is constantly expanding, creating new projects, also expanding its resources. Therefore, it's much better to have a mobile structure now than rather moving a whole solid structure. Then we came up with the third design. As you can see, this is our third design. In this case, we have 2 90-degree angles, which are front and back plates, and then 2 60-degree angles on the sides. Why those angles? Well, there's called a valley angle, which is the minimum angle required for the material to flow. For aggregates and sands, you need to have a minimum of 60-degree angles to have a smooth flow and not get stuck between wedges or just because of gravity. Since we are using gravity to help from the front end loader to each hopper or each chute, we need to have that specific angle. Also, as you can see, these are some of the rough dimensions that we will be using. 14 feet width, which is this way. That 14 width has to do with the size of the front end loader, which is 12 feet. Then we'll have 5 feet in width, 8 feet in height, and then that will give us about roughly 324 feet cubed or 12 cubic yards, which is what the company requires to have, so we have a constant flow of shipment. The next difference is the gate, which instead of the other one was a guillotine gate, this is a half moon shaped gate, which we place underneath each one, so you can see here, and we control also by a piston. This half moon movement is better than guillotine because it's better to close while the material is flowing, and it has a smoother movement. This gate also has a 70-degree angles. It's a little less, a little greater than 60, but it helps reduce the flow so you don't have spillage or clash of material when the material hits the bag. And now this is our skid. It's here you see we have a floor eventually, and then we'll have 4 scales, and in this skid we'll have a compressor to feed each pneumatic piston.
So the loader used, like Nicolas explained, now is a Komatsu WA500 with a bucket capacity of 6.8 cubic yards to 8.2. And the scales that we have used in order to measure the weight of 3,000 pounds for each bag is a 4x4 feet scale, a steel scale, in order to resist any of the material that probably spillage or rain or any kind of the weather conditions.
So our next steps, currently we are on track according to our timeline on our poster, but we still need to further develop our designs and analyze them. The analysis will be done numerical with calculations as well as computational simulations such as stress, deformation, buckling, etc. And also we will build prototypes where we can experimentally test our chosen design. The final design will be chosen based on the results of this analysis as well as feasibility of manufacturing. All our prototypes and final products will be built and tested at Titan America's mine site, But ultimately, our final design will comply with the 3 F's of engineering: fit, form, and function.
So our final remarks are to thank you for the experience of the real-life application of mechanical engineering, have a team working on the environment, and thankful, of course, for Titan America to sponsor our project, Ruben Terraza, that is the aggregates plant manager, and Juan Restrepo, the aggregates loadout supervisor, and of course, thank you to the Florida International University. Thank you very much. Any questions?
Have you been out to Titan?
Yeah.
Have you been out to the plant?
Yeah,
Yes, yes.
I interned there.
Okay.
That's how we got the. I started in June, summer internship, and they extended it. And my boss, which is Ruben Terrazas, he's a mining, has a bachelor's in mining and a master's, I think, in business or engineering business. And he said, hey, I know you have to do a final project. Do you want to stay and continue your internship? And we would like us to sponsor your final project. And I said, sure. And I set out with Juan Restrepo. We mentioned him because he's the one in charge of rolling out material from the finished products to the customers. So he helps a lot of suggestions of how to operate, safety, things like that. So we came up with him, we came up with this project. So, and then we had a day, that's where we took a picture over there. Those are the cement bulk bags that they fill, and we took them out there and showed them the mine site.
Okay. Your manual system fills bags at about 1 bag every 6 minutes. Explain to me how these automated systems, how much better is your system than the current 6 minute per bag approach?
Well, currently it's 1 hour for 10 bags, like you said. This new system, it will fill 4 at the same time, but it would also have the flexibility depending on demand. Flexibility of filling 1 or 2 at the same time, or filling the hopper up. You can fill 1 bag while you're loading the next bag. Our goal is to have about 1 bag every minute-ish. So it's until we do testing, we won't have the final number, but that's our goal so far.
So that'll be one of your goals, is to prove that you can meet a 1 bag per minute.
Right.
Yeah, minute and a half average, depending on forklift ability. Because once
No, exactly, because the filling of the hopper for 4 bags is probably equal to the filling of the hopper 4 times.
and
They're not far different.
1 cubic, each loader is about 7 cubic yards.
Yeah.
And ours is about 12. So about a loader and a half will fill 1 hopper.
Okay.
Each bag is about
38 cubic feet.
30 cubic feet. We have 324 feet cubed, so roughly about 10 bags per hopper. So if we can fill 4 bags in about a minute and a half, then we should be able to beat the manual.
Okay. And my last question is
Yeah.
to uniformity. How can you assure that filling this will fill each bag uniformly?
We will.
Because like they require, the company sold bags for 3,000 pounds. So the scale, they automatically, when the scale is reading probably 2,600, the half moon chute is closing in order to have the exactly 3,000 pounds for each bag.
Okay.
Each scale will have an output. It's 4 different independent scales, and each 4 scale will have an independent reading and a printout, because we have to print out with a sticker. It's an automated sticker, so it will print out the exact weight, and each weight will have, each scale will have its own reading. That's how we can assure the customer and the client.
Thank you.
Is the scale going to shut the hopper?
No, it has to be manned.
So you're not going to electronically connect those two?
It could be a future project. We thought about it with the company. We just, for time constraints as far as the senior project, it will be manually. In the future, if we see that the load is, let's say we're shipping out 200 bags a month, and we need that to be automated, then we would consider implementing that. For now, there would be manual push, shut off, or turn on.
So if you have now 4 bags that are being filled at the same time, are you increasing manpower to monitor those 4 bags individually?
I don't think so, because it'll be, this, the way we're planning on operating is 3 men. 1 operator controlling the 4 bags, controlling the flow of material into the bag. 1 forklift operator to remove the bag, and then 1 loader, 1 front-end loader, so it'll be 3 men. Right now, you would have the 3 men the same, or actually 4 men, because the way they fill it now, you have 2 people holding the bag, or forklift holding the bag, 2 people shoveling the material into the bag, and then you have to carry it to a scale, which the load-out scale, which is about half a mile away from where the material is. So then even if you have the same amount of manpower, you're still reducing time by not having transport back and forth to weigh the material.
My question was more towards if each bag takes a minute to fill and you're filling 4 at a time, you're gonna have to monitor 4 different weights and have the person manually control the feed of 4 individual bags.
Well, we thought more about a circuit rather than 4 continuous fluid feed, filling. Maybe more of a circuit. 1, 2, we would number them, and we start from here. While this one's finishing getting unloaded, you would load this one. So then you have a constant rotation, and you wouldn't have to worry about looking at, we said, 4 different scales at 4 times. And that would be more of a trial and error to see if we can do 4 at a time. If not, we can implement the circuit.
Do you have a budget? Did they give you, okay, you gotta build this for $50,000 or $100,000?
Open budget.
Really? Are you sure?
Yeah.
This is the first and the last time in your engineering career you'll have an open budget.
I'm sure I can't spend $100,000 on it, but we have a rough number, but they never say, hey, you have to do that. I have a rough number in my head. But, there's the way, maybe the way the company works, it's that way. They do have set budgets, but we're putting this, it's not a separate budget for me, it's more of a cost for they put it under their own budget, like expenses.
And seeing how much the product actually helps in profits, the lost in time and lost in material may outweigh the cost or the extra cost.
Well, the reason I asked that is because right now we're designing a gearbox for Raytheon, and we have a very dollar figure that we have to build this for, a time frame that we have to make it within, and a weight capability. So there's 3 parameters, and we have to find them all. That's why I was curious about a budget, because usually a company says, okay, here's $50,000, build this thing. I hope they'll put some constraints on you, because it makes it much more interesting.
Well, we have the time constraint for sure.
Yeah.
Definitely, we would want to get this built and tested before our senior, so we can have actual full productivity before. Obviously, we know that once it's built, we're going to have to make modifications. One thing's on paper, one thing's in real life. They never mentioned, like I said, they never mentioned to me budget. They just said, I have an account with them, so I have my own work order, and I just place anything on there. It gets approved by my boss. Like I said, I don't think I can spend $100,000 on it.
Is your prototype going to be, you going to make a small one of these things, or are you going to actually make a full-size, full capability item?
Well, it's going to be full capability, full size at the mine site, and we were planning on making a show, not a function, but a show scaled down version, so we can bring it to our senior team.
Well, and it depends on the test. For flow test, we might scale it down and measure with a smaller scale with material, sound, and measure how the flow works.
But at the mine site, it'll be a full scale.
Right.
So in the spring, can we all go over to the mine site?
I wish. It's just MSHA doesn't. It's really hard to get visitors into mine sites because of the large. I could possibly arrange something. That'd be awesome. But like I said, I could try, but it's hard that way because of it is a mine. It might not look like a mine site, but it is an active mine site, and they have a lot of regulations for PPE, personal protective gears, and training. But there's ways around it. Any other questions?
Okay, during your presentation, you talked about increasing profits and increasing safety. So, are there baseline numbers that you're trying to do this from? What's that?
You mean a baseline number? Of
Yeah, because
how much
if you're
it
talking about
costs?
increasing
Oh.
profit, you have to
Right.
increase it from something. You talk about increasing safety, increasing from something. So if you're talking about that, and that's what you've got objectives to do, what are you doing it from? You have to have some sort of baseline number to go from.
Well, profit-wise, they haven't shipped out. Titan hasn't shipped out bulk bags. Cement has, but then they have their own system. This is aggregates. They haven't shipped out in about 2-3 years because of this. That's one of our objectives to find out exactly what. So we have to go back and and see how much they actually spend shipping out 10-12 bags a month, and compare it to what our final design will output. So once we know what our final design will output, we can have that comparison and see what our offer increase would be. As far as safety, it's not really a goal, but it's a everlasting increase in safety, because like I said, Latin America is very important about safety. Because it's a mine site, there's a lot of explosives, a lot of exploding machinery. So just having a machine that could fill bags without having to be under a loader or under a forklift, just that's already an increase in safety. I don't think you can put a price on life. So just by saying, I know it might seem that just we say, oh, it's more safe, but in reality, when we have a machine